Welcome back to CMSC 201. I'd like to start with a few announcements. I know that this is a different format than we've had in the previous lectures. I will be switching internet providers, and if possible, we'll be going back to live lectures. But I'm going to try this for now just to see if it's possible that we can make this work. So I'm going to be releasing a series of short videos, each one hopefully about 10 to 15 minutes, but they'll add up to a full lecture. I'll try to put them in a playlist so that they're all searchable. Okay, so last time on CMSC 201, what did we do, right? We talked about if statements, we talked about elif, and we talked about else, and we talked about how to use them in different conditions. So I guess I'll just go over a little bit about if, else, and else, and then we'll talk about a few things before I start on the examples. And the examples, I think, are all going to be contained in separate videos. So this will all be the main meat of the topic, so watch this video first, and then you can watch the example videos. Okay, so if you remember, if you have, say, x is equal to 3 and s is equal to some string, something, then you can have an if statement, right? If x is equal to 3, for instance, we can print, x is 3. If you have an if statement that says if x is not equal to 3, so this is the not equal operator. It's the operator that determines if a symbol is, if basically the equal sign is false. So it tests to see if x is equal to 3, it's not, and so we can print something else. So what are the important things to remember about if statements? If statements start with the keyword if. That's not terribly surprising. But in Python, they all must end with the colon. So remember that this is this is like a syntactic feature. And when I say syntactic, what I mean is that it's a feature that the compiler looks for in the grammar of the language. Right, so it's not what your program means. It's not the x equals 3-bit, right? Testing for some specific thing, that might be the semantics, like what your program is doing. But syntactically, it's required. And so what else do we have? So we have elif and we have else. So remember, things to remember about elif is that only one elif ever gets executed. And so I should really say at most 1. It could be 0. Because, what could happen? So if we have, say, if x is equal to 1, print hello. Elif x is equal to 2, you can print goodbye. Elif x is equal to 3, you can print, say, robot. Elif x is equal to 4, you can print daffodil. And elif x is equal to 5, you can print summation notation. And so basically, if you have this block of if conditions, what happens is your interpreter, because we're in an interpreted language, will read this first one and it will ask, is x equal to 1? In our case, x is still equal to 3, and so it's not going to be true. So it won't print hello, and that means that it goes to the first elif statement, where x is equal to 2, won't print goodbye because this will turn out to be false. Finally, it goes to x equals 3. It finds this one will be true, and it'll print out robot, and then it won't do these, right? It doesn't continue, right? So that's the important thing to remember, is it doesn't continue to execute once it finds a true condition. But it will continue to execute as long as all of the conditions are false. So just remember that all of these are now chained together, right? Only one of these is ever going to execute. So it could be possible that here you notice that I didn't add an else clause. So it's possible that nothing will happen, right? If not any of these are true, meaning it's not equal to 1, not equal to 2, not equal to 3, not equal to 4, not equal to 5. For instance, if I make x equal to 6, then it's not going to print any of these. Right, first it prints x equal to 3 from the older thing, but you notice that here it doesn't do anything. If we assign x to 3 again, it'll print out robot, but then it doesn't do anything else. So this doesn't have a catch-all. And so I guess I should also say that even if you have else-if clauses, which are elifs in Python, you don't need an else, but you're allowed to have an else, right? So an else, what does else do? Else is like the catch-all, do this if nothing else works clause, right? So basically the point is that if nothing else turns out to be true, so if we say, say, x is equal to, well, let's just add it to here. So we say, if, say, s is equal to happy, we print, it is good to be happy. If s is equal to sad, print, it is less good to be sad. If s is equal to robot, robots do not have emotions. Yeah, I guess. And finally, we can say else. What other kinds of words are there? Right, so here what's going to happen is if we, let's just set s is equal to input, enter your word of choice. If s is equal to happy, it'll print happy. If s is equal to sad, it'll print sad. If s is equal to robot, it'll print robots don't have emotions. Else, and so this will execute when nothing else is true. So let's just go and watch it execute. So enter my word of choice. I'm going to put in happy. Good to be happy. So you see that else does not execute. Put in sad. Else does not execute. Robot. Else does not execute. And finally, what's another word that is not any of those things? Armageddon. And so what other kinds of words are there, right? So this executes exactly when none of the other ones execute. So the else clause is an important thing that will catch anything that doesn't execute one of these following if statements. Now, you might not ever need something like that, but you can also always be guaranteed that at least something from here will happen if you use an else. Okay. So that's all from last time. That's all from last time. So the things I want to cover today before we get to the examples are just generally nesting statements. So I want to cover what nesting is, and then I want to cover a few things about what I'm calling short circuits, which is actually the term for it, so I guess I shouldn't say what I'm calling it. It's what it's called. And I'm going to talk a little bit about true and false values from if statements. So let's talk about short circuits. This is the short circuit section. And so let's see. Okay. So sometimes what you're going to do is you're going to need to, here's the best example, here's like the easiest example, is for instance if you say x is equal to int input enter numerator, and then you do something like y is equal to enter denominator, or really divisor, and I guess dividend. That's the top thing, if I'm not mistaken. And so our entire goal is just to print out x divided by y. But, you know, the general rule in life is that whenever you are giving the user input, they're going to say, oh, my favorite number is 17, and then I'm going to divide by 0. Okay, so that's a slight problem, right? The problem is here that you have a zero division error, and the reason why you have a zero division error is because you tried to divide by 0. And so once we learn exceptions, like way later in the course, you might be able to catch this. But there's also, in most programming languages, you won't just rely on catching an exception for this. You're actually going to have to do some safety checking before you let the division occur. So let's do that safety checking. So basically we want to say if y is not equal to 0, we can print x divided by y, like this. So watch what happens. So if we say SDF, and then 17, and 0 again, you notice that the program completed safely. Maybe we should put something in an else clause. You tried to divide by 0. Naughty human. Let's do it again, and divide by 0. So you tried to divide by 0. So the basic point here is that this is the first check that you would do. And now if, for instance, you actually wanted to check to see that, well, let's say that you actually want to check to make sure that maybe x divided by y is, say, less than or equal to 10, right? So let's check this, right? If y is not equal to 0 and x divided by y is less than 10, less than or equal to 10, then we'll print x over y. So here you notice that there's actually a little bit of danger, right? The danger is that there's a y not equal to 0 here, but there's also this and condition. So it's going to check to see if y is not equal to 0 and if x divided by y is less than or equal to 10. So if x divided by y, if y is equal to 0, then we may end up with a problem again. But let me show you why we don't. And the answer is, let's divide 10 by 0. And so you tried to divide by 0. So how did it not just fail here, right? It wasn't going to try to execute this. But why didn't it try to execute this division? So the reason it didn't try to execute the division is called short circuiting, which basically means that as Python reads from, say, left to right in this case, the important thing to realize is that if one of the conditions in an AND statement, so if you have, for instance, A and B and C, and this is your if statement, right? This is the condition inside of your if statement. But you know that A is already false. Then you don't need to evaluate anything more, right? So that's why this x over y does not get evaluated. So not this x over y down here. We should just print, say, the condition is true, right? Rather than trying to divide. So here is the only problem with the division can be in the if statement itself. Won't be evaluated unless the first statement is already true, right? So that's the thing that saves us from the zero division potential here. So, and let me just show you that it doesn't work in reverse. So if you did something like this, let's try again. Enter dividend 10, 0, and we're going to hit enter. We get a zero division error. So if we flip them, right? So this is the bad one. And the reason it's bad is that it divides first before checking. So this is just a nice little behavior of if statements and logic in general, right? It basically takes advantage of the fact that you know the truth table for and. You know that if the first thing is false, it doesn't matter what the second thing is, right? So that's essentially the trick here, is that if this thing is false, then we don't have to look at this. If this thing is true, then we do have to look at this. But the good news is that this first condition here is the safety check to ensure that the second condition won't die. So that's why the short circuiting works to our advantage when we put it in the right order. Okay. So there's also short circuiting for, say for instance, on the matter of OR statements. So short circuiting for OR. So if we think about it, and you can think about it in just a second, but you know. So this is basically what I'm going to give you. We're going to have A is equal to, say, true, and B is equal to false. Now, if you think about it, lowercase b. If you think about it for a second, you'll realize why short-circuiting will also happen in an OR statement. Now, think about it this way. So remember, for the AND statement, if the first condition was false, then the, let's say the condition, or the expression, didn't check anything further. Just returned false. Now, for an OR statement, we have to remember what's the truth table for OR. OR requires that A or B is true, so that means that if A is true, then the whole statement's true, or if it's B is true, then the whole statement is true. So if your problematic thing occurs in the second, let's say, second slot of the OR, then if the first thing is true, then the second thing won't be evaluated. So let's actually test this out with some zero division stuff. So if you say if A, let's just say if x is equal to 0, or y divided by x is equal to 2, print, let's say one of those two things was true, right? So this is not a very meaningful statement. This is just testing if x is equal to 0, or if y divided by x is equal to 2, then else print not that. So let's go through this and see what happens. My word of choice is always ASDF. Let's see, 10 over 5. Okay, wait, no, I needed the other way, 5 over 10. So the first thing I need to do, because I'm doing y divided by x, actually I should just switch to x divided by y because that's what we had before and it'll be less confusing for me and everybody. So let's put 10 over 5. So you see that one of the two things was true because 10 divided by 5 is equal to 2, so that's right. And so we're good, right? So that this part of the OR statement worked. You notice that x was not equal to 0, but that doesn't matter because it's an OR statement, right? So if the first thing is true or the second thing is true, then the whole statement is true. But now let's make, now we should change y. It didn't actually matter in that example, but we should change it to y so that it's actually the right denominator. So now let's say we're going to do another 0 division, so 10 divided by 0. And then it actually still says one of those two things was true, right? So it printed out this statement here. The reason why it did was it checked and it saw that the denominator was 0, right? So here it sees that the denominator is 0, and so it's happy, right? The OR statement is already true. It doesn't need any more prongs, I guess you might say. If you think about, if you have, for instance, A or B or C or D, etc., you know, it only requires one of these things to be true for all of them to be true. So, or not for all of them to be true, but for the expression to be considered true. So here, when y is equal to 0, it doesn't need to go on, so it doesn't. So it's actually, this is another way to save you. So remember on the previous one, we had to set if y is not equal to 0, so that when the denominator was 0, this thing pops out false, right? And then the and will terminate. Here, if y is equal to 0, that pops out true, and true or x, or I shouldn't say x since there's already an x, true or alpha, where alpha is some expression, is true. So we don't need to evaluate the second condition. So that's essentially short-circuiting. I think that's really all we need to talk about in terms of short-circuiting. It's just something to think about. It's something that can help you later on in life. All right, and then the last thing that we want to talk about before we talk about nesting is if statements that cast certain things to true and certain things as not true. So the first thing I'm going to do is, because we have so much code already here, I'm just going to, you don't have to look at that. That's future stuff. That's a function. But just pretend like it's not there, right? So pretend that that code is gone. There we go. Perfect. So the last thing that we want to talk about, as I said, is the evaluation of variables as either true or false. So basically each type, each of the standard types in Python, and remember what the standard types are: int, bool, float, string, has a kind of is true, right, built into it. And so what I mean by that is that if we say set my variable equal to 4, and then if we just say, and so you notice that the type of my variable, if we print out the type, it's going to print out as an integer. And then if we do my var, if my var, print my var is considered true, right? Else print my var is considered false. And so let's print this out and see what happens. Cool. So you see that I didn't hide anything up my sleeve. My var is truly an integer. It was set equal to 4. And then all I did was I said if my var, right? And you might say, well, that's not really a condition, right? But what it's asking is my var true? And so the answer to that question is determined by, is my var equal to 0 or not? Right, so let me prove that to you. So let's type in, say, int input, enter my var, and that way we can actually enter it. So say -1, -1 is true, 5 is true, 17,841,233, that's true, 0, that's false. So this is kind of shorthand. It's shorthand for whether or not a variable is coded as 0 or not. And the secret reason for that is that when Boolean was coded into binary, basically true is usually equal to the number 1 and false is equal to the number 0. But here's the thing, even a Boolean variable is 1 byte, and so a byte is equal to 8 bits, and each bit is a 0 or a 1. And so when we talk about binary, we'll get into this a little bit more, but the thing is that basically a single byte can either encode all the way down to minus 128 up to 127. So that's the range of a byte, as long if it's signed, or alternatively 0 up to 255, which, as you might know, is 2 to the 8th minus 1. Maybe I'll even use the Python power notation. So the point here is that anything that isn't 0 is just considered true. So if a Boolean has anything in it, right, 2 in its variable, 17 in its variable, 254, whatever, it's considered true. And so integers follow the same pattern. And so that's something that, integers follow the same pattern. So integers are considered true whenever they are not equal to 0, and they are false exactly when they're equal to 0. So you notice that my var is true even if my var is negative, positive, really big, really small, etc. The only thing it can't be is 0. So that's basically the moral of the story for that. So what else do we have? Well, we have 3 other data types. We don't actually have to think about Booleans, really, because as it turns out, a Boolean is true when it's true and it's false when it's false. And so what I mean by that is for Boolean types, basically all you need to do is you need to look at the fact that, if you say we have some Boolean is equal to true, and then you say if b, print b is true, then it's going to print that b is true. Let's enter -1 again. And so you notice that b is true. And then, of course, if I say false, and I say false, print b is false. And so you see that this is how Python will evaluate a single Boolean if you stick it in as either true or false. Now, of course, this shouldn't be terribly surprising because Booleans have true and false values already, so they should be expected to have some kind of thing like this. Whereas integers, it's a little harder to say unless you're really, by this point, it's kind of intuitive for me to think this way, but maybe if it's new to you, then you have to kind of drill it into your head that true is equal to basically 1 and false is equal to 0. And the simplified version of that is false is equal to 0 and true is equal to really anything else. Though when they actually encode the Booleans, you'll notice that they actually encode them as 0s and 1s. But 2 is just as true as 1, 3 is just as true as 2. Everything is just as true as everything else except 0, which is false. And so you might ask, okay, so we've gone through 2 types. What about floats? So floats basically borrow from integers. Now for a float, I guess actually it does work out the same way. If the exponent is all 0 and the mantissa is 0, then it would just all be a 0. So it does actually work the same way. But if we have, say, my float is equal to 3.412341235, I guess, that's a number. It's a floating point number. And then if I say if my float, print floats follow the same logic as ints, right? And so you ask the question, do floats follow the same logic as ints? And the answer is yes, right? Because the program told us so. It says, if my float is true, if my float is true when my float is not 0, and my float is false, and I guess I should technically capitalize these just in, like, true as in the Python keyword true, but also evaluated as true in the evaluation as well, right? Maybe I'm being hyper vigilant about the distinction between true, the Python keyword, and the concept of being a true statement, but let's ignore that kind of philosophizing for a second. So here, my float is false when my float is entirely 0. So you can create a floating point variable. So for instance, my 0 float is equal to 0.0. We can print out the type of my 0 float. Now type is forbidden in this class, but I'm using it just because I am proving to you that it is in fact a float, right? So you don't need to use type for anything until we explicitly tell you that you can use it, and we probably won't. Most of the time we don't want you to be messing around with type. The only reason why I'm using it is just to prove that things are what they are. So here is 0 floats are true, else print 0 floats are false. So, okay, let's consider what happens. So as it says, you notice here it says class float. We'll talk about class later, but this is just telling it's a float type. And here it's saying that 0 floats are false. And the good news is that that is correct, right? If this thing were true, it would print out that 0 floats were true, but it's not true. It goes into the else clause and it prints out 0 floats are false. So that's basically the moral of the story for floats. Floats are evaluated much the same way as integers, so there we are. I think the last thing to talk about before we go on to actually nested if statements are strings, right, of course, are the last data type. And so if we think about strings, how is a string true or false? And so this one is not as easy, right? Because you can't say like, oh, a string is equal to 0, right? Because then that would be an integer. It can't be this, because then this would actually, this is a string containing the number 0, and you wouldn't want that to be false. Generally, the way that strings are done in most languages, and I think I'm just going to say most of the time, most places, is that an empty string is false, a non-empty string is true. And so, yeah, let's talk about it. So let's write down some stuff. So first string is going to be equal to ASDF. If first string print non-empty strings are true. Else, I guess, print non-empty strings are false. Okay, but this should never execute, because as long as what I'm saying is true, then this one will go, this one will never go. Let's do another string. Let's just call this one empty string. And then let's do our standard coder trick. Copy paste. And so here we get empty strings are true. Empty strings are false. And then here's the trick. So let's say we have a string with a bunch of spaces, and maybe let's even throw in a tab or two. So I know I haven't talked about escape sequences yet, but this is me talking about tab escape sequences. To get a tab, you use \t. And to get an end line, you use \n. So for instance, we can have a string like this with, this is all white space. If we print it out, white space is equal to this. If white space, then we should say white space. Strings are true, and otherwise we print out white space strings are false. And so let's run this program and see what happens. 1, 2, 3 as usual, to skip that one. So let's see what it says. It says non-empty strings are true, empty strings are false, and white space strings are true. And so be careful with white space, because an empty string is purely a string like this. The other empty string is, as you probably are guessing, this. I just deleted everything. Okay, let's hit enter rather than delete everything. Slightly better plan. All right, so basically, these are the two ways to make an empty string, or alternatively, you can, I guess the third way to make an empty string is that, but you don't need to use that. So I think that's all I really have to say about it, other than, yeah, I think that's really all we have to say about that. So I think what we're going to do now is I will begin the actual topic for today, which is nested if statements. And so basically, I'm just going to say that when we say nesting, and I might cover this in the separate videos about the examples, because I'm going to do a few, maybe I guess 4 examples of nested if statements, and that's what I'm going to do. So when we say nesting, what we mean is like Russian nesting dolls, right? You put one if statement inside another if statement. So for instance, if I have A is equal to true and B is equal to, say, false, and then I do something like this. So here's the first example of a nested if statement. I can have if A, which will execute if A is true. I can then say print A is true. And then in here, if B, well, let's say if not B. So I haven't really shown you this before, but what does this do? Right, the answer is, remember that not inverts logic, so it flips true versus false. So if A is true and B is false, then not B will be true, so it'll print out B was false. Now, why might you want to do this, and how does this differ, right, from if A and not B? Print A is, other than the fact that it's going to be on 2 separate lines, right? Well, we can even use an end line. There we go. So how are these two things different, right? And the answer is generally that what you see is that the second if statement on the inside here, you notice that the internal second if statement is tabbed in another level. So if it's tabbed in another level, that means it's all inside of the first if statement. So let's think about, before we execute it, and I know that you might be thinking exactly what's going to happen, but let's think about it before we run the code, because it's always good to think about what you're doing before you just plug and chug. So here, if A is true, it's going to print this out. And if B is also true, then not B will be false, and this won't print, right? So that's the difference. The difference is that if A is equal to true and B is equal to true, then the first print will happen in the top code, but not in the bottom. So sometimes you need that to happen. So sometimes what you need is a condition where if you go into one if statement, you might even get some more user input. So you can't be reliant on an and statement because you won't know what the user is going to input, or it could be reliant on some calculation. You won't know until you do the calculation. So here, the if not b statement is executed only if a is true, which is the same in this this statement, but it also can not execute if b is also true. Whereas here, it requires both of them to be correct, a being true and b being false, and then and only then, right, will this thing execute. So let's see what happens. So let's make a true and b false. So let's prove that they both do the same thing. Let's enter 2. So here, a is true, b is false, right? So they both print out the same thing. But now let's flip this b to true and see what happens. Enter 2 again for lack of imagination. So here we see a is true, which is from here. This didn't print because b was not false, right? B was true, so not true gets mapped to false. If false, doesn't execute. And so here, if a, this is true, and not b. So not b was true, not b was false. So we have a true and false, which gives us a false. And so this doesn't execute. So you see that in the first condition, in the best condition where a is true and b is false, I don't know why I called it the best condition, the most permissive, the most, validated condition, the condition where the if statements are all true. So in this condition, they both look the same, but in this condition, they don't look the same because this one will execute, and then this if statement will execute and determine whether it should print. And so you can kind of see the applications here, right? Because a lot of the time you're going to need to do multi-tiered logic. So and keep in mind that you can also pair all of this, right? This is nesting if statements. You can pair all of this with else clauses. So for instance, else, if b print, a was false, but b is true now, right? So you can pair this, but this is not considered a nested statement. This else is not nested. This if statement inside is nested. So this one is nested. Actually, I'll just put it here. Nested. And this other one is nested. And then if you add another variable, say you say c is equal to false or something, and in here you can even have an if c, right? Print c is true, right? So here we have a doubly or triply nested statement. I guess you would call this a triply nested statement. Probably. Because there's basically 3 levels. I guess in that sense, then a single if statement is a quote unquote singly nested if or something. I guess we're counting from 1 and not 0 like true computer scientists, but whatever. Okay, so the point is that you can pair all of this together, and so this is the kind of conditions that you can actually make. And so a number of people ask, is there some limit on the number of, for instance, elifs that you can have? And the answer is there is not a limit, right, on the number of elifs you can have. But if you have more than, say, 50, 50 is a huge number. Say, if you have more than 20, you should think about what you're doing. And a similar thing for nesting of statements. There's also not really a limit on nesting. Eventually when we get to loops, but really if statements right now. Right, so there's not really a limit on nesting. But again, if you nest more than 4 levels, then maybe rethink, right? So I might give you a homework problem where you end up with 4 levels just to make you do it once. But the point is that most of the time, you're going to try to actually de-nest your loops if you can. Move more and more of your code out of like more and more complicated nesting blocks, because it is eventually does become a little bit more difficult to think about. So yeah, there's not really a limit on nesting if statements. These are really recommendations. So don't pretend that these are hard and fast rules. Like if you have to, in a project, for instance, nest 5 levels, then if that's the only way you can do the project, then that is exactly fine. Great. We're not going to take off points for like a quintuply nested if statement, but the point is that if you find yourself doing something like that, that's when you have to take a step back and think, do I really need that? Or is that something that is a little bit excessive? Okay, so at this point, I think I've covered what nesting if statements are, right? Nesting if statements are sticking if statements inside of if statements. And so I think that's all for this part of the lecture. So I'm going to have, I think, 4 examples of nesting if statements, and I'm going to record those as separate videos so that you can watch them individually. All right. So that's all for this one. I'll see you in the next video.